tough questions.
Okay.
Ask us about Roundabout lighting.
I was feeling for you.
There's Doug and Ryan.
They're backseat boys.
Yep. Cole? My hands are.
Come on in, grab a seat. We'll get started in just another minute.
8:30 is early.
It's early. I know. Be about 8:45. People still kind of rolling in with their coffee.
Especially with breakfast, too.
Yeah, man.
Did you have a good day yesterday with the boys?
Okay. Well,
You got through all the wind all right?
Yeah. My wife messaged me. I was here. My wife messaged me at like 3:30. She's like, "It's sunny and the birds are chirping. I'm so glad we had to miss a whole day of school for this."
Well, if they wouldn't have, it would have come harder.
I know.
And, you can't win that
We
one.
can't win.
Oh yeah.
No, we swapped out that day.
My mom texted me that yesterday. I was like, dude, I don't care at all. Like,
Give it to 8:30.
Well, I saw some people have the little flower things or like leaves on their name tags.
What's that?
St. Patrick's Day.
Oh.
So I was confused by
Oh, it is today, isn't it?
Yeah, yeah.
look, Ken's. Oh wait, no, it's got green.
Yeah, I got my
All
little
the green on it. I
checks.
got a green on
Green undershirt. You're double
He's
protected,
doubled
huh?
up on it. I just got my
I did.
little shamrock on my name badge over here. It's
So were people handing those out or like where?
they're up on the registration
Okay.
table.
That's
If you need some
I did.
green, I
I
won't
deserve
pinch
a
you.
pinch.
Yeah,
before
you're
then, so.
in danger.
I got nothing. I got nothing.
I was considering my Grinch socks.
You guys
too.
ready?
Yeah, I'm good.
All right. All right, we're at 8:32, so we'll go ahead and get started this morning. Good morning. My name's Jordan Woodard. I am with the NCDOT Roadway Design Unit. I'll be your room host for this session. We have two presentations lined up this morning. First is going to be Roundabout Staging and Temporary Positive Protection, presented by Mr. Ken Thornwell from NCDOT Work Zone Traffic Control, followed by the NCDOT Roadway Design Manual Roundabout Guidance Update, presented by Lily Cloud, Ty Smith, and Mike Lindgren, all of them from the Roadway Design Unit. Please join me as we welcome our presenters.
We're gonna switch.
Yeah, we switched the order on you, Jordan. All right, well, thank you guys all for coming out here. Hopefully we can get you some answers on the changes that we have made and answer any questions we can for you. So with that said, let's get into it. So I'll give you a brief history of roundabout guidance in North Carolina. It started with NCHRP Report 672 that came out in 2010. And we essentially added a link to that into the Roadway Design Manual, and that was about all we did. Then in 2023, the next NCHRP report came out, which is 1043, and we added a link to that as well. And then later in November, we added a little bit more guidance to the design manual. And that brings us to today, or I guess in March now, but in February, we released the update where we've taken a little bit more guidance. We've gone a little bit more in depth. So what we've done here is we identified some challenges from projects throughout the state, as well as coordinated with other states, Wisconsin and Florida being two of them. And then we used that and combined that with guidance from 1043 to create the NCDOT roundabout guidance. So what have we actually added? We've made changes to two sections. The first one, 824. This one is an overview of roundabouts. And we've also made changes to 810, which is our design guidance. So chapter 8.2 is our types of intersections. So this is going to give you an overview of the different types of roundabouts. There are 4 of them. The first one, and kind of our default, is going to be a single lane roundabout. The next one is a mini roundabout. These are going to be rural, typically smaller volumes, smaller speeds, and they're generally an upgrade from a 4-way stop. The next one is going to be a multi-lane roundabout. We at NCDOT are highly recommending a 2x1 as the biggest. If you find a location that you think a 2x2 would work, you are more than welcome to talk to congestion, see if you can get that worked out. But due to some challenges we've had with them in the past, we're highly recommending a 2x1. The final type is going to be a modular roundabout. Modular roundabouts are essentially plastic curbing that's put up very quickly. They're very cheap. They're very quick to put up. However, they do have some issues with life, with the length of their life. So then to get into 8.10, this is our design section. So this is not going to be the only design guidance you're going to need for roundabouts. You are still going to have to use the NCHRP report. However, our goal here is to orient designers with what we want you to do with a North Carolina look for it. To get into that, it's going to start with the roundabout design process. So what we mean by this is roundabouts are very, they can be optimized for whatever you need them to be. And so what we want you to do is we want you to pick certain things that you can optimize your roundabout for. We have a list of them up on the screen, but that's not all of them that you can optimize for. And I'll read them out to you. We have speed control, pedestrian and bike accommodations, large design vehicle accommodations, high capacity, and right-of-way impacts. You should take a look at your project purpose statement, stakeholder input, your location, any information you have on your project. Try to think about which of these would be the most important for that location. Then, as you are making decisions and designing your roundabout, we want you to keep these important things in mind. When you're designing a roundabout, there are a lot of decisions that you can make that will give you benefits on one side and have drawbacks on the other. So we want you to try to think about that and balance those decisions as you go through the design stages. There are 2 design stages that we have outlined. The first one is initial design, and you will notice initial design is not a part of the PDN. The reason for this is because initial design can happen at multiple PDN stages. So we chose that to say that if you are the first designer looking at it in a functional or feasibility study kind of timeline, then initial design would happen then. If the project did not have a feasibility study, then initial design would happen at the start of DRPS. To get into what initial design is, we're going to highlight these 6 things here. The first thing you're going to do is lay out your alignment. So that's going to be horizontal and vertical, as well as the location and size of your roundabout. The location of the roundabout is something that we want designers being a little bit more intentional about. We do not want to just take the center of that roundabout, the center of that circle and put it where your alignments cross. You can shift that circle around to get a lot of gain in terms of approach angle and stopping sight distance and all these other things. Once you have your alignment set up, you need to look at your legs. There's 2 different types of legs. You've got approach legs and departure legs. For your approach legs, we want to make sure we are slowing people down. So this means gradually decreasing radii on curves. And I'm going to say gradually again. We want to make sure that we are not just putting a really sharp curve right there coming out of maybe a 60-mile-an-hour road. Then for departure, we are looking to allow people to accelerate out of our roundabouts. We don't want to be putting chicanes on our departure legs. And something that goes hand in hand with those last 2 is going to be truck aprons. At NCDOT, we want to do our best to minimize truck aprons for pedestrian issues, which we'll talk about a little bit later on in the presentation, but also for cost. Then you're going to lay out your bypass lanes. This is going to be your right turn bypass lanes. Once we have all of that set up, we can take a look at our fastest path calculations. For anybody who doesn't know what a fastest path calculation is, essentially this is a line that we draw through a roundabout that represents theoretically the fastest somebody could drive through it. Once you have your fastest path calculations, you are likely going to have to iterate back through this entire process. You're going to have to take a look at your approach legs. You're going to have to take a look at your alignments. You may have to shift where your circle is. We want to highlight this. This is not something that you are going to do one time. You are not going to put your roundabout down and get it perfect right off the start. You're going to have to go back through and make changes, look at what is impacted by the decisions that you make, and try to balance those changes. The final thing you'll look at in initial design is going to be driveways. We are okay with commercial driveways being attached to roundabouts, but they need to be designed as a leg of the roundabout. So you need to think about everything that you would think about if that was a regular road. Residential driveways we want to avoid on roundabouts. Our next and final stage of guidance that we have added is our DRPS expectations. If you take a look at this section, you're going to see the words confirm, review, revise, a lot in this section. That is because, as we've said a couple of times now, roundabouts are very iterative. You're going to take what you've done in the first couple of stages, and you're going to look over it, change it, see what you can improve, see where your weaknesses are to try to get the best roundabout that you can. 2 things that we're going to add at this stage as well is going to be sight distance calculations. So that's going to be your stopping sight distance as well as your intersection sight distance. And then we're going to add details for our islands. So we made a few changes to roundabout typical sections, and so that's what I'm going to talk about right now. You'll see across the top we have typical written there. That is because this is a typical section. This is not our default. This is not our standard. We do not want to see everybody putting 12, 18, and 10. Right? This is not NCDOT requesting these numbers. This is us saying that this is a good starting point, but that you should look in guidance and find numbers for your project. Now, there's 4 changes that I'm going to highlight here. First up, we have the A1, the truck apron. Then we'll talk about R2, our rolled curb. We'll talk about pavement schedule, and then we'll talk about R3, which is our modified 2'6" curb and gutter. Curb and gutter is the NCDOT recommendation for all roundabouts. The reason for this is because curb and gutter has inherent speed control compared to just a shoulder and pavement markings. People are much more likely to ignore a line on the pavement than they are a physical curb barrier. And so for that reason, we are recommending it. However, you don't have to put it on your entire corridor. You can put it on just the limits of your roundabout. So from about 6 months ago up until 6 months ago, truck aprons had been 7 inches to 12 inches in depth. But now pavement design is recommending they be 12 inches due to some of the cracking issues that we have seen on truck aprons. Now, some of you may not have seen a rolled curb before. I know 1'6" curb has been used a lot in the center of a roundabout. We are recommending rolled curb as a standard for the center of your roundabouts. As you can see, it has that smooth face, which allows a truck to transition across this from the pavement to the truck apron a little smoother. We're going to highlight there's 2 types of rolled curb here. We have a 3-inch rolled curb and a 2-inch rolled curb. The 3-inch is going to be our standard, and the 2-inch is generally going to be used when you have higher low clearance traffic, so something like low boys. The other thing I'm going to highlight before I move on is you will see the left-hand side of these rolled curbs has that 12 inches to match up with the depth of our truck aprons. Then the other side is going to be 9 inches or 10 inches, depending on which one you are using. Because our rolled curb has a 9-inch face instead of the 7-inch face that's standard on a lot of our curbs, we had to make some changes to our pavement schedules. The math did not work out with minimum and maximum lifts, and so now what you're going to see on roundabouts is going to be 9 inches of pavement, and so that's going to be 333 for surface, intermediate, and base course. And you can see that in the orange, yellow, and red. The other thing I'll talk about here is you'll notice across the bottom of that maroon, that is a layer of base course as well. The purpose for this is that we wanted to make a continuous and flat subgrade line under all of our roundabouts. This will make it easier to construct because the grading is easier and the paving operations are a little easier as well. Now, as you may have guessed, we have changes to all of our other curbs. So this is our change to our 2'6" curb, going from the 7-inch face to the 9 and 10-inch face. So we do not want to run these modified curbs and pavement schedules throughout an entire project. We want to make sure we are stopping them somewhere around the limits of the roundabout. Exactly where you stop that is really case by case, if you will. This is a good thing that you can coordinate at a field inspection meeting. So talk to your division, talk to your construction staff, and see where they would like to end it. And the final typical section thing I'll talk to you guys about today is truck aprons. So as I said before, there are some pedestrian concerns with truck aprons. If you're a pedestrian, you see a sidewalk and another sidewalk in front of that. So if you as a pedestrian are waiting in the truck apron when a truck approaches, there is a conflict there, and that's something we want to try to do our best to mitigate. One of the easiest ways to do this is to not have these truck aprons. They're expensive and they have that issue. So for us, we are trying to do our best to minimize truck aprons. You can take a look at this and mess with your approach legs, and that can generally help you with accommodating larger design vehicles. And with that, I'm going to pass you guys over to Lily to get a little bit more into the design.
Thank you, Ty. All right, so what we have learned through developing this guidance is that designing a roundabout is a bit of an art. So you're constantly trying to balance the core design principles, which are balancing speeds, promoting visibility, guiding drivers, and accommodating large vehicles, and then wrapping all of that up together into one design, and then making it work as a whole. So for example, having larger entry radii might make your truck movements a little smoother. However, in turn, it will make the operating vehicles enter a little faster, which can make unfavorable scenarios for pedestrians. So you really have to consider the trade-offs behind each decision that you make. So we've added new subsections to the roadway design manual to help designers understand these fundamental design principles, and these include the location and shape of the roundabout, vehicle capacity and lanes, speed control, speed consistency and fastest paths, entry angles and vehicle path alignment, and sight distance. And so the designing for large vehicles section also got an overhaul. We removed some information that we best felt was covered by NCHRP 1043, and we have added some additional information about truck aprons based on feedback from pavement management and the divisions. And we have also added some information on how to design accordingly for truck-heavy locations. So sometimes when you begin the design of your roundabout, it can be tempting to place the location of the circle, like shown on the left there, on the location of the existing intersection to avoid any property takeovers. However, that is not always going to be your best option. So in some cases, as you can see there on the right, shifting that circle is actually going to do a much better job of fixing those poor approach angles as well as improving how that intersection really works. So that's that balance that we were referring to earlier. Ideally, like on the right, you're gonna want your legs to intersect that circle as close to 90 degrees as possible. And so this is something that will take a few iterations, a few tweaks. You're probably not gonna find this location the first time, and that's okay. Really just take time to see the impact when you choose different locations. So for roundabouts on higher speed facilities, you really want that driver to begin slowing down ahead of time before they reach the circle and then enter and then circulate through that roundabout, because otherwise they will be going too fast. And so, unfortunately, posted speed reductions alone are not effective. The geometry must provide that speed control. If the driver has an opportunity to drive faster than the posted speed limit, they will. So this is why we added this figure to our guidance. This figure was based on examples from other states, such as Wisconsin and Florida, as well as the AASHTO Method 2 super elevation tables. And something else to keep in mind while designing these approaches is to ensure that the island is long and wide enough to provide that speed control and pedestrian accommodation, but not be excessive at the same time to help reduce cost and minimize your footprint. So now let's go through an example using this high-speed roundabout approach figure. So I'm going to say that my facility entering here has a design speed of 50 miles per hour. And so I'm just going to use the values from the tables here. Let's say that I selected my first curve, having a radius of 1,050 foot, and then that 100-foot tangent. Curve 2 would be 425 feet, and then you have that 50-foot tangent, and then let's say a selected value of 100 foot for the last one. So you can see on a high level, overall, these radii are getting smaller over time, reducing the speed of that vehicle coming into the roundabout. And so we wanted to mention that ultimately, this methodology was included as a best practice. So these are recommended values. And if your project and your conditions dictate that you use something else, that is okay. This example is also for a tangent approach. So curved approaches or other project conditions may lead to different values to achieve that speed control. So this next slide illustrates roundabout natural path, which is a term that you may or may not have heard before. So it's essentially the path that the driver will actually take as they are traveling throughout that roundabout based on how the intersection is laid out. And so this is critical because it's giving insight to how the driver's actually going to react and travel through that roundabout, and not just how it looks on the plan sheet. And so this is why laying out all of your vehicle swept path movements is very important to help put yourself into the perspective of that driver. And then from there, you can begin adjusting things like the entry, the splitter islands, or the central island to help how those vehicles are tracking. So this is particularly important, as shown there, for 2x1 multi-lane roundabouts, where that correct lane choice needs to be clear early on. And speaking of 2x1 roundabouts, here is a new figure that was added to the Roadway design manual to help designers visualize the concept of spiraling within a 2x1 roundabout. So in simple terms, that basically means that the vehicle path is going to progressively shift towards the outside so that the drivers are naturally aligned with their exit when it is time to leave the roundabout. So roundabouts require 4 different types of stopping sight distance checks to make sure that the drivers can see what they need to at different points in that roundabout and stop if necessary. So NCHRP report Exhibit 912 through 916 depict these different checks. So you need stopping sight distance on the approach, at right turn bypass lanes, at pedestrian crossings, and around the circulatory roadway. So we added references in our guidance to these exhibits to help draw attention to them and how they lay out where on your roundabout and your approach legs you actually need to calculate that stopping sight distance from. And so after talking through those 4 stopping sight distance checks, let's start talking about our intersection sight distance checks. So there's only one figure for those, shown here, Exhibit 917, that basically tells you that that intersection sight distance needs to be calculated both at the yield line as well as 50 feet ahead so that the drivers are not waiting until that last second to see the circulating traffic. So we also added a reference to this exhibit in our roundabout guidance to draw attention to this figure and the associated formulas. Let me get water break, sorry. Okay, so roundabouts can have a bypass lane with yield or merge geometry, as shown in this figure that is now in the Roadway design manual. So the layout should match the condition that you want the drivers to respond to, because that distinction is not always obvious in design. So a yielding bypass lane should ultimately have the same kind of geometry that an intersection does, where you have those sightline considerations that the driver can see to the left easily, and then ultimately assess when the correct time is to move forward with that gap. And then if you would like to have a merging bypass lane, it's critical to ensure that you have enough side-by-side parallel length in order for the driver to merge comfortably. So unlike a yield or merge condition, where the driver may be stopping or slowed down before entering the roundabout, drivers that can enter freely can really bring a lot of speed into that roundabout if the geometry allows for it. And this is why fastest path is so important. So as Ty mentioned earlier, what the fastest path really is just a computed version of each movement, what the fastest theoretical speed that a driver is able to go. And one important concept with fastest path is that you're checking each movement not just to ensure the speeds are not too high, but also consistent among each other. And so this will take multiple iterations to get, but it is a very critical element of roundabout design. So here's a location where delineators had to be placed as that curbing was not providing sufficient deflection. And this is the kind of issue that fastest path analysis can help to bring up in the design so that maybe that geometry could have controlled that instead of the delineators. So the roundabout drainage guidance was updated to be in line with the current NCDOT hydraulic guidance. So since roundabouts are lower speed environments, your spread and hydroplaning concerns aren't going to be as bad. So your drainage still needs to work well, however, be careful of over-design. A big point in the roundabout drainage guidance is to keep those drainage structures off the vehicle path, especially on the inside of the roundabout. So the better place for inlets is going to be usually along the outside curb of the approach leg before the driver is reaching that yield line. So this is also a good place for coordination. So if you're the roadway designer, you may do the geometry, get the drainage design back from hydro, and then maybe you see a box show up right where the driver is going to drive over it. So that does not automatically mean anything was done wrong, and sometimes you just can't avoid it. But it's still worth working together with hydro to see if maybe the geometry on that design can be adjusted enough to get that structure out of the vehicle path. So here's standard drawing 815-02, which is the subsurface drain for installation in grass medians and roundabouts, which was added to the 2024 standard drawings. This is the standard to look at when you have a roundabout with a grass central island and it needs drainage. And the main benefit of utilizing this is to make sure you're keeping the center of that roundabout draining well and not creating a big muddy maintenance issue. So usually your interior truck apron is going to be enough to accommodate trucks in a roundabout. But in higher truck locations, like an interchange roundabout with a nearby truck stop, exterior truck aprons may also be needed. And that is something designers are running into more often as these roundabout interchanges are becoming more common. So truck aprons and geometry adjustments do help make room for larger vehicles while still keeping the roundabout doing what it is supposed to. So accommodation should always be based on the design vehicle for your project. There's a lot of different large vehicles that all have different swept paths and different design considerations, and they need to be focused on specifically. And so, as mentioned earlier, with exterior truck apron design, you want to be really careful to be intentional so that you're not adding too much truck apron on the outside and it is getting confused as a sidewalk. So it's always worth checking, as we mentioned earlier, if you can adjust that circle and help to maybe create better truck movements through that instead of just placing external truck apron all over the place. And so there's also some roundabouts like this one shown here that have other creative methods for large vehicle accommodation. So as mentioned earlier, it's an art. You can get creative with it as long as there is intent. So the Roadway Design Manual is a living document, and it is typically updated every May and November, and then in this case, February for the roundabout version. But just to bring it back and kind of discuss with you guys, this was the first enhanced NCDOT specific roundabout guidance, and we have more roundabout specific updates expected in May. So if y'all have any feedback, lessons learned, or general experience working with roundabouts, please reach out to us and share. It would help us a lot as we're continuing to develop this, again, with the industry's help. And we would love to help review and consider your feedback into future updates. So any comments you have for the Roadway Design Manual can be submitted using the contact form on the Roadway Design Manual website shown here. That's
Good morning, everyone. My name's Ken Thornwell. I'm the State Work Zone Engineer for the North Carolina DOT. And I'm going to chat a little bit more about roundabouts from a phasing and constructability perspective. Talk a little bit about how some of the challenges we have when they go to construction. And then once we get through that, I'm going to change gears a little bit, and I'm going to give some updates on positive protection in work zones. Specifically, I'm going to focus probably a little bit heavier on portable concrete barrier, but I'm going to touch on the updated Code of Federal Regulations that was passed last year, and then I'm going to wrap it up with some information on crash cushions. I always put this in here. If you're a vendor or a supplier and you see your product on there, it's not because I like you better than anybody else. It's because you're the one that I have a picture of. But yeah, so anyway, going into the roundabout construction. So when we go to build a roundabout, traffic control really becomes the name of the game. Throughout the construction of that roundabout, we're going to have to keep people pointed in the right direction. Patterns change. Users, whether they're bicycles, vehicles, trucks, pedestrians, we're going to have to change their paths during construction. And the goal is we need to keep them comfortable getting through from one phase to the next until that permanent pattern is complete. So some of the big challenges that we have when we go to construct them, number one, alignments. Like I said, the alignments will change during construction, probably more than once. The lane shifts and the tapers as we go to construction, we need to make sure that we're designing those in accordance with MUTCD and North Carolina DOT standards, that we're giving drivers great channelization with our drums, cones, and skinny drums to make sure that they understand which way we want them to go. The super elevations, I heard Lily and Ty talk about the super elevations. Super elevations and work zone traffic control, they cause us headaches a lot of times because it seems like every single time there's a super elevation to the left, the permanent design wants a super elevation to the right. Right? Doesn't sound like a big deal, but it can be hard to construct. So as we're wedging that pavement, or if we're milling, or whatever needs to happen, we need to make sure that we're maintaining positive drainage, that we're not getting bird bath conditions during that construction period, and that our design speeds are acceptable as folks come into these changed super elevations. When it comes to the center islands and the splitter islands, right, these usually get installed a little bit later. The center islands, sometimes we can do a little bit earlier, but the splitter islands, a lot of times, are one of the last things to get installed. Ty and Lily talked about slowing those vehicles down when they come into the roundabouts. The challenge that we have in traffic control is that those permanent features, those permanent curbs are not installed yet, so it becomes difficult for us to slow those drivers down, especially if it was like a two-way stop prior to construction, where the main line had a free-flow movement, and then now all of a sudden we are expecting them to slow down and traverse a roundabout. Pedestrians, you can see my little guy on here. He ran around that entire intersection. Even though we don't have striped crosswalks here, we do have sidewalks and curb ramps on basically every single side of this intersection. Federal law requires us to maintain pedestrian movements at all times during construction. Our ADA conditions need to match existing during construction. And so that creates a lot of challenges for us in the work zone condition as well, right? We have to build a lot of temporary features in order to accommodate pedestrians. And then lastly, temporary signals, temporary signs, temporary markings. As we go through construction, we've got a signal at this intersection here. At some point when it becomes a roundabout, that signal needs to come out. But in the interim pattern, while we're building that roundabout, that signal is very much in the way. So we need to build a temporary signal to get the poles and the span wires out of the way so roundabout construction can continue. So same intersection here. This is the public hearing map for that intersection, and that just makes my brain hurt. From a traffic control perspective, where do you even begin, right? What do we build first, right? you can see that there's a lot of construction happening outside of the existing pavement. So what do you build first? Where do you put things like your temporary signal poles? Where are you going to put the pedestrians during construction? So this was the final plan. So in the green boxes are all of our temporary pedestrian accommodations. Got some purple boxes there. The designer called out some temporary drainage items. And, these are the kinds of things that we need to include on temporary traffic control plans, because these are the things that are going to make it easier for the pedestrians to get through, for our bicyclists to get through, and then for our contractors to know what they need to build and at what point during construction they need to be installed. Here we go. Nice, easy one. Lily talked about moving the center of that circle off the intersection. So, nice, easy one, right? The circle is outside of the L line. The Y lines are pretty much on same alignment. The islands can be built away from traffic. There's no pedestrians out here, 2-lane roads, minor super elevation changes. Everything looks wonderful until I pull up the profile, and it's 3 feet in the air for 500 feet.
Hey, it's better than cut.
So the only way to build that approach on the bottom there was under full closure. So the challenge that we have there is that, full closures, this one in particular, was not identified very early in the plans. This one was identified a little bit later. So we didn't have quite as much time to do all of the things that we have to do for a detour, right? Work zone traffic control, I fully support closing every single road as much as possible in order to do the construction. We'll talk about that when we get into positive protection. But we do have to do some things before we just close the road. We need to analyze the traffic routes and the detours. We need to make sure that the detour route can handle the additional traffic volumes, that we're not going to have issues at traffic signals or railroad crossings, low bridges, weight-restricted bridges, making sure that the pavement surface along that detour route can actually handle the traffic, make sure we don't have to do any widening for turns or anything like that. So there is, a little bit of analysis that has to be done on that detour route. It's not as simple as just close the road and send the cars around. Even if the roads themselves and the intersections are okay, we still have to coordinate with our stakeholders. We have to check with our division folks to make sure that they're comfortable with it. Our emergency services, schools, the local governments, utilities. Just had one come in the other day that we were possibly proposing a closure. Duke Energy said, well, hold on now, I need to get my giant trucks in and out because this is a staging yard where we keep all of our telephone poles. So I don't even know what design vehicle that would be, but it's a very, very big one. Public communication, once the decision to close the road is going to move forward, we still need to provide the public that advance notice, right? Daycare is what, $15 a minute if you're late picking up your kid. So that's when I talk to my designers in traffic control, that's what I tell them is it's like, yeah, you might only be delaying somebody 5 or 10 minutes, but if they are not at that daycare at 6:01, then it's costing somebody real money. Right, you are ruining somebody's day. And then on top of that, timing and duration, like how long is this road going to be closed for? Are we going to put liquidated damages on the contractor? How do we determine how long it's going to be closed? Do we have to calculate quantities? So this one here where we've got all that fill that's got to go in, does that take 10 days, 30 days, 60 days, 90 days? How long does it take? So we need verification on those quantities. And then once it actually goes to construction, we need to make sure that the plans have everything that they need, because when that road gets closed, if we need to make changes because signs weren't included or we didn't have what we needed in the plans, sign fabrication could take several days, sometimes even weeks. So if we need to make a change, it might be a week before that change is actually implemented in the field. So all of that to say, If we're going to close the road to build the roundabout, fully support it. Just make sure that we plan it accordingly. Other things during roundabouts, interim pattern changes. So when we build a roundabout, a lot of times we have to work on multiple legs of the intersection at the same time. Sometimes that means that we can't keep every lane open that's out there today. So if we have to do turn lane closures or through lane closures, we just need to make sure that we're mitigating those impacts. The situation here, I think part of it was the roundabout construction, part of it may have been some drainage items that they were trying to install, but we ended up having to close a through lane for long duration, and immediately, the very next day, 2 miles of queuing, and every single day after that, 2 miles of queuing, right? So this is another situation where with some level of traffic analysis, if we could have identified this earlier in the plans, we may have been able to put some intermediate contract times on this to make sure that the contractor gets these items completed quickly. Right. One of the major strategies, and you can kind of see it in that aerial photo there, is when we build these roundabouts half at a time. We'll see it in construction occasionally where one direction will be still running on its tangent alignment, and then the other direction will get put into the half circle pattern, because that's how the roundabout is getting constructed. Again, it just kind of boils down to just making sure that we have the signings and markings in place to make sure that drivers understand what we expect them to do. So this one here, they designed it with most of the center circle could be built at one time. They managed to get the traffic in the circulating pattern. But what I really wanted to highlight here is the temporary signs and the temporary markings that are shown on this traffic control plan. Designer did a great job, because a lot of times what we see in here is it's like, oh, we'll just install the permanent signs. But the problem that we have is that none of the islands are installed yet. You can see here a lot of these islands are still under construction in this phase. So if the island is not there, we can't expect the contractor to put the permanent sign in. So if the permanent sign can't go in, then we need to show that sign as a temporary sign on the traffic control plan, so that way the traffic control contractor can order those signs and have them installed on temporary supports. All right, so I'm going to change gears a little bit. I'm going to go into some positive protection stuff. So positive protection, basically any device that we put on the road to redirect vehicles and keep them from running off the road, hitting workers, running into a ditch, hitting a bridge pier, whatever the case may be. The most common, the most well-known are probably portable concrete barrier. That's what we see on most of our major projects. And then also truck-mounted attenuators. A couple of things that we had to do, and I'll get into this in a minute, but some key definitions here. High anticipated operating speed, North Carolina DOT, we define that as 45 miles per hour. And then no means of escape. So when workers have no mean of escape, that means that they do not have an unimpeded path at all times. So these are going to become important in just a minute. So as part of this update to the Code of Federal Regulations final rule, we have a positive protection analysis guide that we'll be issuing some training on later this spring. But basically, you can kind of see there's this whole list of items in there when positive protection may be used. But the big thing that I like to say is yes, positive protection. When a vehicle strikes, positive protection, the benefit is that it is a controlled collision. Positive protection devices are crash tested. They are deemed as safe or majorly safe. I don't know how to say that, but the problems that we have with positive protection or the risks is that when we put concrete barrier down in 70 miles of I-95, we are going to increase crash frequency. That is a known fact. When crashes occur, it is going to take longer for the tow trucks and the police cars and the ambulance to get there. It is going to increase the likelihood of a secondary crash. Positive protection is going to cause issues with drainage, sight distance, it restricts oversized loads, reduces access for the contractor to get in and out of the work area. And then there is actually tremendous worker exposure to install and remove it, especially if it's anchored. So the soapbox that I like to carry around with me is yes, positive protection, it reduces the severity of crashes, but it does have the potential to kill people itself. So I think the big takeaway on this slide here is that we want to minimize the use of positive protection by either getting the traffic away from the work or getting the work away from the traffic. Right? That's the message that I like to take home is if there's an opportunity to not use positive protection, let's not. If we have to, then we will. So this is the updated federal rule I referenced earlier. This became effective last year, and I highlighted the important parts for us. So Federal Highways requires every DOT and every single city, municipality, every single government agency that does work on the roadway system with federal dollars has to define high operating speed, has to define no means of escape, and has to define engineering study. Basically, the long or the short of it is that if those three things are true, high operating speed, which we have defined as 45 miles per hour, workers have no means of escape, and if it is a federal aid project. If those three conditions are true, the Federal Highway says that you shall use positive protection unless you do an engineering study to eliminate it. It sounds like a big change, but in reality, it's not. I can't think of a single project in the state of North Carolina right now that would require positive protection based on this rule that doesn't already have it. So, we're doing a great job there. The big change, though, is that if you choose not to use positive protection for whatever reason, the federal requirement does require an engineering study now. So there is actually like a 10-page engineering form that has to be filled out, and somebody's got to sign and seal it and include it in project documentation. Like I said, we're going to start offering some trainings on this coming later this spring and summer. I anticipate that this will occur on 2 or 3 projects in the state per year at most. Right? This is not a huge thing for us because, as I mentioned, we already do a great job including positive protection on the projects that need it. All right, moving along. So portable concrete barrier, that's as I mentioned the most common one that we use in North Carolina. Deflections between 1 to 4 feet. The big difference here that I wanted to talk through is the difference between NCHRP 350 and MASH 16. They are 2 different types of barrier. Unfortunately, we can't control which one the contractor brings to the site, and I'm going to walk through some of the differences between them. NCHRP 350, contractors are allowed to continue using it if they have it in their inventory. However, they're no longer allowed to manufacture it. So as we move forward in time, we will start seeing less and less of the 350 barrier, more and more of the MASH 16 barrier. But one of the big differences is that the MASH 16 barrier actually has to be anchored on the ends. Even if you have unanchored barrier shown in your plans, the ends of it still have to be anchored into the pavement. In addition to it, I know you can't see it, but this is a new standard drawing that went into the 2024 specs. And I put in the red box because this is, and I tried to blow it up there, but this is causing a little bit of heartburn for us, is that MASH 16 barrier can only be anchored on the traffic side. We cannot put pins on both sides of MASH 16 barrier. So that means that if we're running a concrete barrier down the middle of a bridge or down the middle of a facility with traffic on both sides, we pretty much can't use anchored barrier. It's got to be on anchored barrier. So that's a change that we're working through. Next here, this is the anchorage that I was talking about. So on MASH 16 barrier, there's a special provision now that goes into all the projects by default when you have concrete barrier. Basically, what it says is that if you have concrete barrier, you can only be anchored on the traffic side. We cannot put pins on both sides of MASH 16 barrier. So that means that if we're running a concrete barrier down the middle of a bridge or down the middle of a facility with traffic on both sides, we pretty much can't use anchored barrier. It's got to be on anchored barrier. So that's a change that we're working through. Next here, this is the anchorage that I was talking about. So on MASH 16 barrier, there's a special provision now that goes into all the projects by default when you have concrete barrier. Basically, what you see here is on the right side of that standard drawing is the crash cushion, and then as traffic moves past the crash cushion, the first two pieces of barrier have 3 anchors apiece, then 2 anchor, then 1 anchor. So we had to figure out, how do we pay contractors for this? Right, they actually have to go out there and drill holes in the pavement and hammer anchors down. So the way that this standard special provision works is that if it is a transition from a crash cushion to unanchored PCB, then that transition is incidental. We are not paying for it. That is just part of the crash cushion. But this transition requirement is also required when we are going from unanchored barrier to anchored barrier. So think about if you're running down the road, you have unanchored barrier, you're going underneath a bridge, and underneath the bridge we need anchored barrier. We will need this transition on both sides. And the way that this is going to be measured and paid is it is just all counted as anchored barrier. So as soon as that transition starts, the contractor gets paid for anchored, and then as soon as they get under the bridge, out the other side, and transition back down, that's where the end of the anchored barrier pay item would be. All right. Transitions between guardrails and concrete barrier. We see it all the time. Contractors love to just tuck concrete barrier behind guardrail. They like to just cut the guardrail off and tuck the guardrail or tuck the concrete barrier behind it. Ideally, we don't want them to do that because what we're trying to do is maintain system tension, right? Ideally, we want that guardrail unit to be tied to the end of the concrete barrier. So preference number 1 is the BR77 connection. If that doesn't work, then we do have this standard drawing in the book, and it gives some guidance on how you can transition from a guardrail section to a barrier section. So just keep that in mind as you're designing it. You know, we can't just put crash cushions right in front of guardrails. We either need to put the guardrail in front of the barrier with, I think it's 3 feet. It's kind of small, I can't read it, but I think it's got to be tucked 3 feet behind it. And then you also see there's, it's hard to see on the screen there, but there is a requirement for some temporary pavement to make sure that that barrier is not sitting in the dirt. All right, and then, yeah, let's see here. Temporary crash cushions. So some of you may have gotten it already. This memo actually went out this morning. Effective with the May turn-ins. So that means like in 40 days. If you need to use a non-gating crash cushion, we need to call that out in the plans. So if you're familiar with gating or non-gating crash cushions, gating crash cushion are the water-filled the water-filled crash cushions that you're starting to see on the interstates a little bit more. They're just as good. They will slow a vehicle down. They will have a controlled deceleration. But if they're struck on an angle, there is potential for a vehicle to penetrate through it and end up behind the barrier. As long as your barrier length of need is what it needs to be, shouldn't be a problem. As long as you're not in front of a deep ditch or have fixed objects behind that crash cushion, shouldn't be a problem. If those conditions are not met, if somebody running through that crash cushion would cause a problem, then we need to call it out as a non-gating crash cushion. There's going to be a different cell in the cell library. We're going to ask that you call it out on the plan with a note as shown. And then, but yeah, that's pretty much it. No changes to pay items. Again, this is handled in special provisions. Special provisions are added by central contracts. Moving on, water-filled barrier. The other soapbox that I always carry in my back pocket is water-filled barrier. If I see water-filled barrier on a plan, it is an immediate red flag for me. Yeah, there's my note at the bottom. If you can make water-filled barrier work, you can also make concrete barrier work. Concrete barrier is half the price of water-filled barrier. Concrete barrier's minimum length is less than water-filled. Yeah, water-filled barrier is a favorite item of contractors for some reason, but it is nothing more, in my opinion, than channelizing devices, because the minimum lengths are very, very long, the deflections are very, very high. A lot of them are, especially the initial lengths, they're gating systems, so if a vehicle strikes it, there's high chance of penetration. And then if you're using them in the wintertime, we've got to put antifreeze or salt or something in it, and depending on what the contractor uses, we can't intentionally drain it across the pavement, right? You actually have to get a vac truck and suck the antifreeze back out of it. So, like I said, if you can make water-filled barrier work in your design, I think you could also make concrete barrier work, and it is cheaper and easier to install. Lastly, we get a lot of questions about steel barrier. Similar to PCB, but we've gotten questions in the past about, are we going to make this a standard? Are we going to put it in the spec book? Are we going to have standard drawings for it? The answer to all of those questions is no. And the reason is because they are all proprietary designs. They're all a little bit different. So typically what we're doing is we're allowing contractors to submit RFIs during construction to say, hey, I want to use steel instead of concrete. If that's what they want to do, then if you're in construction unit, just send those to us. We'll review them. We'll take a look. But some of the challenges with it is it does have a slightly wider footprint. It's about 4 or 5 inches wider than concrete. It does require anchoring along its entire length, like every, I don't know, 16 feet or something. It's got a very, very large curve radius. But the contractors love it. Probably the second bullet there under their lower shipping costs. They can load, I don't even know what it is, 300 linear feet on one truck, as opposed to the 7 sticks or something that we get of concrete. Contractors claim that it's faster installation. I'm still waiting to see that. It seems like it takes longer every time I see it. But yeah, it's much lighter, it's lower shipping costs, and yeah, so if you guys get questions from folks in the field, I think we've called it out on one project. It was a drawbridge project down in Wilmington. But otherwise, when we use positive protection, we're just gonna call out, you know, the concrete guardrail, one of our standard items. But that's all I have. So appreciate the time this morning, and Jordan, I guess back to you.
Okay, there we go. So we do have a little bit of time left in our session, and wanted to open it up to any questions that folks might have. I'll do my best to run the microphone out to you so that everybody can hear. But if you have any questions that you'd like to ask our presenters, please raise your hand, and I'll try to get to you as quick as I can.
Art McMillan, GFT. Is the roadway roundabout standards going to give a standard for how the alignments ought to be done? In the traffic control, 2 examples had 2 different ways of doing it. Do all the alignments go together? Are they offset? Does the roundabout need an alignment? Does the roundabout need a grade? On the high-speed chicanes, does the chicane need an alignment and a grade? Mike, you're up.
Well, since I got out of the presenting, I'll answer questions. You know, we're seeing everything from A to Z come in. The roundabout should have an alignment, should have a grade, following the NCHRP guidance. It rolls 2 to 4%. And then strategically placed in your low point. We've seen, you know, the alignments, we've seen them come in, just, you know, come in and cross and do all the layout. As long as the contractor can lay it out, I think you can have the alignments go through and tie. But we're also seeing alignments that come in, you know, and follow the vehicle path and just tie to the outside of the roundabout. So the typical section for the roundabout and the roundabout grade should tell the contractor how to build the circle to the outside inscribed diameter. and then the grades for all the approaches should come in and tie to that, regardless of where the horizontal alignment comes in. We've seen some where it's like a ramp coming off, and they get the speed control, and they put the alignment straight in, so it doesn't follow. Nothing tells the contractor how to build that curvature. So I think there is some benefit to making it more simple for the contractors. But again, we haven't put that in the design manual necessarily, how to do the alignments. Wisconsin had some champions of early 2000s, and they went deep. And we went and we met with them and tried to ask how'd you guys come up with all this? And they were like, those guys are gone. So, and that's where we're at. I mean, we're early, really, in trying to provide consistent design so that our drivers know what to expect when they see that roundabout ahead sign. We shouldn't have 36 different, I guess, the way it feels to go into a roundabout. We should try and set the expectation for the next one. Did I answer? I guess the alignments.
We do provide some guidance towards both profile and horizontal alignment in our guidance. As far as some of the more specific scenarios that you were addressing, I think that's a great place if you'd like to read it and give us our thoughts on the alignment sections. But seriously, we do include some information on that. And as Mike said, there's not always just one right way, and so we might not prescriptively say you have to do it like that, but there is information telling the designers what is necessary. So definitely check that out.
Yeah,
So we have a figure that depicts that, and that there's additional information on how to develop that with the curvature to have the speed control elements.
and we've heard the reduced cost.
What do you mean?
You can either have the two, but they've got to, they got to work out with the splitter island. If you have a splitter island the whole way, if you have one, you have to do your detailing to where the contractor can lay it out. Again, if you have the alignment, you can keep the O2, right next to your alignment, and the island can stay level. But if you have one alignment going straight in with your profile, and you detail it out, then you're kind of setting an effective grade on your chicane if it doesn't follow directly with the alignment. So, but we're trying to provide flexibility and safety and driver expectation, how you get there with the design, as long as it makes sense and the contractor can stake it out and build it. I think we haven't really set a certain way to do it yet. No, I'm just kidding. No, I don't think we will.
Yeah, I want to add to your question there. I think not providing the guidance, I think, works better just because every project's going to be a little bit different. And also from the way the software and the modeling behaves, I feel just my own perspective on this, having set guidance on this is how we want to put the alignments in, puts a lot more restrictions, kind of ties the hands from the design perspective. I think leaving it to, because we got to look at the super elevations and the way the traffic flows, plus the drainage, plus the traffic control, phasing, everything. I mean, it all kind of plays into that initial setup of the alignment. I feel if we have a set guidance on it, that kind of ties designers' hands on just being restrictive on that design. I feel I'd probably be a lot more flexible. I think if they leave it to the designers and then the project team to kind of have that flexibility to design that roundabout and have the outside alignment versus the inside centerline alignment tie-ins or the edge alignment tie-ins work out with the drainage and everything. It just me historically, it just helped me get some projects. It was nice to have that centerline tied in versus having that edge tied to the roundabout. It just depended on the project and the profile, the way the topo worked. So I don't know. It's just my thought on that. Leaving it open kind of helps with those decisions.
Yeah, and I think we tried to be very prescriptive early with roundabouts and say you need to do them this way, but it's such an art that you have different objectives. So you have different ways to design them, and they're going to look different based on if you're at an interchange or if you're in an urban setting. So, yeah, we just tried to provide the flexibility since we've just referenced the NCHRP reports. And so we haven't been, everybody's found out the way they understand and the way they want to lay them out, and we just don't want to be too prescriptive.
I had a question. I think Ken mentioned the phasing plans. This is one of the toughest things to do is the phasing on roundabouts, and it kind of goes back to the roadway design. The first profile that's put in on the roundabout, if the profile either wasn't given too much thought on the phasing, or sometimes it's just the way the topo and the right-of-way dictated the way the profile was put in. Are there any guidance out there? I haven't read the new manual, but are there any guidance on the NCHRP or roundabout that kind of has these recommendations on, I think, just the roadway design, the way this profile's set up and all? Just in general, I'm just asking. I haven't looked at other guidances, but historically it's been just word of mouth, experience and talk with people, and you learn more as you go. But design more roundabouts, you learn more. So.
We have talked in construction on the roundabout committee. We received a comment that we're seeing way too much wedging, and I have yet to see a roundabout typical section that shows wedging and shows, we just show new pavement because a lot of it is new pavement. It's hard to cover the scenario. And so we did add in the design manual to just pay attention to the grades. If you are over existing pavement and it might be used for traffic control, to try and use those controls to try and set a resurfacing control to try and minimize the wedging in the roundabout areas. Would you have anything to?
No, I mean, the only thing I would say is that new pavement construction in these roundabouts is very difficult. Unless that roundabout is built way off of existing alignment, we're either going to be looking at temporary pavement or like Mike said, lots of wedging.
This might be splitting hairs, but since I was involved in creating the templates that are going to go in ORD, the 2-inch roll curve versus the 3-inch roll curve, that seems like splitting hairs to me, that we're allowing both or both are acceptable. If I'm a designer, I'll just go with the 2-inch roll curb and all of my roundabouts will be low boy ready. Is that, Ty, you gave that as an example that's kind of one of the reasons for doing that. Is there anything else designers need to be thinking of besides just accommodating a low truck?
Well, the 3 inches. The 3 inch is the standard, which is interesting that you make that point, though, that you would opt for the 2-inch each time and technically have it low boy ready, right? So that's just interesting to hear that feedback.
Yeah, and I think having the additional, it does seem like splitting hairs. Right now, a lot of folks have used the 1'6", which has the 5-inch reveal and a 12-inch back because it matches, and they're seeing a lot of those trying to get away from that. And we've seen both 2-inch and 3-inch recommendations. The 2-inch, they say, is not as visible, even though, 2 versus 3, I don't know. 33% more. No. Anyway, the nerd. But no, they say, you also want it to appear to be a truck apron and have some relief to it. So it's a toss-up.
It's another trade-off.
Another trade-off. But if you know you're at an area that has a lot of low boys or if your roundabout has a lot of grade to it, that might it might cause that 1 inch might make a difference in breaking a RV gas tank or black tank or something like that. Sure, or it's really location context.
The other thing I'd highlight on that is the 2-inch has a 10-inch face, so you're putting an extra inch of pavement over your whole roundabout, if that's what you choose to do.
Because of the decision to go with 12-inch, it's going to be pretty standard from what we understand. We pushed for 10-inch because that would have made it nice and clean with the 7-inch faces and all, but for the statewide standard for the depth of the apron, I think pavement design felt much more comfortable saying 12-inch statewide, which projects that are out there now are going to, just coordinate with pavement management if you don't have one, but probably go with 10 inches or higher if they're already designed that way.
So then I change your 2.6 on the outside to a modified, instead of it being 9, it's going to be 10?
Well, modified will cover both.
Yeah, there's two different standards, one for the 2-inch and one for the 3-inch.
All right, we have time for maybe one more question.
Just a recommendation, can we put some cameras so we could get those airborne car videos from these roundabouts?
You mean when we stop the bullet?
Yes.
Yeah, we should do that. No, we've got a lot of, I mean, everything is in evolving. Greg's here, he's working on, our recommendation to fully light if we light a roundabout, and that's a whole decision and a whole process in itself. But our design guidance will evolve. We need feedback. I'm learning every day about, I see a roundabout and I'm like, why'd they do that? And, but you look at it from a new perspective, from a fresh look, and try and figure out why things were done, and just try and help our public know what to expect when they see a roundabout. So lots of different ideas, lots of different design approaches.
I guess I got a comment. I don't think we should expect our contractors to bid a different curve going from modified to non-modified for your smaller roundabouts that tie in pretty quickly. They're not gonna switch over to regular 2'6" curb and gutter just for another 50 feet and another pavement design. I mean, they're just gonna carry the modified all the way out. And when we're doing the ones where we don't, do the reverse alignment to slow them down on the main line, it's just, plop one in there and you got small tie-ins on all four. And I don't think that's gonna be an option. I think they're gonna bid it one way or the other, truthfully.
Yeah, and we work with the construction unit to come up with what they would like to see for constructability. Where would we make that transition if we make it? So yeah, I don't disagree. If it's, in a long corridor and you got a roundabout, you got to figure out where to stop it. So they thought carrying it down to the radius points coming out of the roundabout.
It's a long one, but it's one of the quick replacement ones. It's gonna be one.
Right. Yep. Anything else? Any others?
All right. Seeing none, we're right at our time, and we have about 30 minutes before our next session. So go out, stretch your legs, talk to a few folks, and we'll be gathering again at 10:15.
This is 30, and then 15. Yeah.
Good job, guys. Fantastic.
Yeah. Thank you.
What do you think? Good.